Hello. Hi, my name is Andy Minoski, and I'm the Principal Product Manager for Cryptography and Security Products here at HashiCorp. What that means is I focus primarily on how we look at top-level strategy from like a corporate strategy perspective, as well as how we build and iterate on security products like Vault, Boundary, and special projects that come up related to security, defense, national intelligence, et cetera. And so today I'm here to talk to you about our focus on zero trust, which is probably one of the most overused terms in all of InfoSec and cloud computing, basically to talk about what that means to us and how to contextualize it in the context of both modern DevOps workflows as well as specifically those within AWS. So many of you have probably heard of HashiCorp before, but for those of you that have not, HashiCorp is a company that has an open core model that focuses on supporting and building tools specifically tailored around the modern developer and platform engineering infrastructure system. Today, our products, which include Terraform, Consul, Nomad, Vault, and Boundary, just to name a few, are fairly popular and used both within the open source community as well as with their enterprise and HCP variants across a significant portion of the Global 2000 and Fortune 500. In fact, I think around 200 of the Fortune 500 currently use them in production for mission critical workflows, et cetera. So suffice to say, our products are fairly common, and we are really excited to work with a very large open source community to iterate on them and support really connecting, provisioning, securing, and running any kind of infrastructure for any kind of application. I've used the word modern a lot. I kind of want to contextualize what I mean by that. So in terms of modern infrastructure, we frequently talk about sort of modern infrastructure as really three key tenets. There is no trusted perimeter. So the definitions of where the perimeter sits with regards to specific IP domains, specific subnets, et cetera, may or may not exist. And there are a number of reasons why that may be the case. We'll kind of go into that. But suffice to say, we assume that that is the case. We assume that there isn't necessarily specific trusted access. Now, that's a possibly incendiary term. What we mean by that is that sometimes the specific article that we may use to attribute a workload or an individual or a user, et cetera, may vary depending upon the context in which we're using. And that's very different from traditional models of security where, my one X509 certificate or my one PKI cert or my one Active Directory credential may or may not be like the key defining barrier upon which I define who I am. I might have multiple ways of defining who I am. And finally, the data itself may be unsecured. There may be very sensitive pieces of information that are within that data. That data is going to go everywhere. I don't necessarily know where all that data is going. We have to assume that this is the case. With the infrastructure approach that we take with what we call zero trust security here at HashiCorp, everything that we do within that infrastructure is authenticated. There is a specific verification of a user, an entity, a workflow, et cetera, that verifies that this operation should be going on regardless of wherever that operation is being executed. The second one is that every action is authorized. A little bit different here, that specifically not only do I attribute sort of who is engaging within that workflow, I also verify that that person or entity or et cetera is authorized to be able to do so. And then finally, the data is always protected. Regardless of wherever the context of the data is being executed, any sensitive information there, and again, you define what sensitive means to you, is protected sufficiently pursuant to whatever compliance regulations, data security requirements, step profiles you have, et cetera. So when we say simple, I think if anyone has a security background here, they might take issue with the terminology of saying that securing a data center used to be simple, and they have rightfully every good reason to do so. I think what's simple here is sort of we know where the barriers lie. You know roughly what your threat model is. I know where the perimeter sits, and I know that's trusted because you wouldn't be on my network if you weren't entitled to be there. You wouldn't be physically within the data center if you weren't entitled to be there, et cetera. The barriers there are very well defined. Trusted access, because I know where the barriers are, I know where the entrance points are, and thus I can be able to verify that you have access to be able to access that information, whether it's physically, over the network, et cetera. And then, as a consequence, I know where the data is going to go, so it is at least seemingly easier to be able to secure that data both in flight and at rest. But this complication starts to happen when I start to move between multiple data centers, and ultimately when I introduce different types of environments as a whole, whether they be physical environments, virtual environments, environments in the cloud, serverless environments, et cetera. And this is kind of where modern infrastructure comes into play. The reality is, across all of these, as I move to different types of environments, this challenges the conventional models of security around secure access, securing identity, securing sort of the actual movement of data itself. And this is really interesting because ultimately, this isn't something that we necessarily choose. This is just how the world is going to work, right? Our applications are going to move to the places where they need to be executed. The data is going to live where it needs to reside. We need to figure out a way to be able to ultimately deal with sort of that disruptive but still very exciting movement of data either to the edge or across different types of environments, some of which may not exist within 10 seconds. And ultimately, this is really where HashiCorp as a company kind of exists. Our focus, whether we're talking about Vault, or we're talking about Terraform, or we're talking about Consul, et cetera, really focuses on how do we build infrastructure for the movement from what we would call static infrastructure, an infrastructure where those boundaries are very well defined, sort of I know where everything is supposed to be, et cetera, to a dynamic infrastructure, a modern dynamic infrastructure where maybe I have a private cloud in there, maybe I have a hybrid cloud environment, maybe I have different types of environments where, for example, I am using Kubernetes or another type of scheduler of your choice to be able to deploy certain types of workflows. I need to be able to have that consistency of I identify what workflows are there or what users will be accessing it. I verify that they have the rights to be able to do whatever they're trying to do, and the data that they're using is sensitive and secured across that entire infrastructure. That's really when we talk about provisioning, securing, connecting, and running any kind of infrastructure for any kind of application, this disruption to multi-cloud and multi-infrastructure, and I think you'll start to hear the term like platform engineering, multi-platform, is something where we really focus our efforts as a company. In the context of security, this sort of transition to a world of diverse ecosystems and diverse environments in which computation occurs has also led to challenges, unfortunately, with regards to that infrastructure. There are a lot of statistics here that really talk about how over the last 10 years, data theft, data security, and cyber attacks as a whole have dramatically increased, with the consequence being nearly $1.5 trillion in damages, according to at least data breaches over the last 15 years. I don't have to tell probably most of the people in this room how significant these can be, but as someone that works with a lot of the Global 2000 and their teams, I mean, security has moved from a world where it was seen as a quote-unquote cost center to now it is a boardroom level discussion where CEOs can and have gotten fired from like Fortune 500 companies for not adequately protecting the infrastructure of their customers, of their users, of the people whose data they ultimately shepherd as a consequence of their business continuity operations. That's just a significant, like, matter-of-fact kind of consequence here. And so when we talk about that disruption of moving from static to dynamic infrastructure, we really focus on how do we deal with the consequences of not getting this right. Yeah. And so zero trust security to us is really, don't trust anything. Authorize and verify every single thing that could possibly occur within your infrastructure. And the focus of our products really is about doing that. Our security products, anyway. The way that I actually contextualized this when we were first developing something called Boundary, and really how we look at sort of the idealized world of where we'd want to move to with zero trust security is something that we call the city of doors model. So imagine we're trying to defend a home. If you were trying to make sure that your home is defended against an adversary that was trying to break into it and steal things, there are a few things that you need to think about. You need to think about, for example, does the adversary know where you live? Does the adversary know your patterns of accessing it? Do they know how your door is locked? Do they know it's inside your house, et cetera? There's a lot of things to be challenged about and concerned about. And rather than seeing sort of the disruptive aspects of how modern infrastructure is kind of all over the place, there's a lot of like ephemerality within how data, applications, environments are spin up and spun down, we see that as actually a positive thing. So instead, what if instead of having a static home, you got onto a bus every day and you don't even know where your home is. You step off the bus and instead there is a street with a series of doors. And depending upon the context in which you're trying to be able to actually go home and conduct whatever operations you want to be vis-a-vis going to sleep, watching television, eating food, et cetera, you go up to a door, insert your key, which verifies you are who you say you are, and it has ingrained within it the roles and access requirements that you have, et cetera, and just turn it, and suddenly the house builds around you. As it assembles, it builds everything you need within that house. You walk in, do whatever you want. The user experience is perfect in terms of it just feels like the house is there the entire time. And when you're done, you go off to work the next day and step onto your bus, the house burns down. There's nothing there to go break into. There's nothing there to steal. It makes it very, very difficult to be able to launch concerted types of attacks that we've seen as being the primary mechanisms to employ for data breaches, where I do kind of a low and slow sort of wait, watch, spearfish my way through an adversary's infrastructure, or rather our infrastructure. And so this model of there's nothing to steal if I burn down the house every time I leave and the house builds itself up every time I come in, and I don't even know where my home is in the first place, is the ideal of what we're trying to get to within Zero Trust security. We see 4 components as how to build that within modern developer and sort of DevOps infrastructures. The first is how we handle machine-based authorization. So for automation, especially within applications, how do I handle authenticating that machine-based workflows are able to handle those 3 tenets, right? Identity, verification of role, as well as the securing of data within those contexts. The second one is machine-to-machine-based access. So going back to that kind of model of if I don't even know where I live, it's really hard to follow me home. Being able to adapt and actually use the variances of network infrastructure as a mechanism for defending that whole infrastructure. Finally, human-to-machine-based access. While machine-to-machine-based access and human-based access frequently use the same types of IDPs or identity platforms, there are certain specific contexts there about the workflow of how a human might access a system. It's very different from how a machine might access a system. And dealing with sort of those complexities is very important too. And then finally, the human authentication and authorization that's entitled therein. This is actually very interesting. You'll notice that we got some really colorful sort of logos there for each one of these things. We don't have one for the last one. The last one is because you probably already have your own IDPs. You probably already have your own mechanisms of supporting what you would consider to be identity, whether it's with AWS specifically, things like AWS IAM roles, EC2 instances themselves, et cetera. There are a variety of different ways to be able to verify an application, a workflow, a user, and you probably already have them. We don't want to break that. When we say secure, connect, provision, run any kind of infrastructure for any kind of application, we mean any. And as a consequence, we respect that you probably already have a way of verifying identity. Our job is to align with it as opposed to replace it. So with regards to the machine-based part, our probably most popular security product, as well as our most popular security open source project, is something called Vault. Vault is a tool that focuses on orchestrating data security for any kind of workflow, for any kind of application, but it specifically is well-tailored for machine-based automation workflows. It was first released as its 0.1 release in 2015, and today it's become fairly popular because of its very unique approach to how it handles data security and identity management. So when we talk about Vault, one thing that's very different from the very beginning of Vault versus other ways of how you might protect a secret is that Vault will never try to tell you what a secret should be. You know what a secret is. You know what's sensitive, what's not. Whether it's a phone number, whether it's a PKI cert, whether it's a credit card number, et cetera. You can protect that within Vault, and Vault is not going to tell you that you can or cannot do something because of the nature of that secret. Also, going back to kind of what I talked about before, one thing that's very different with Vault is we're not going to tell you what identity platforms you should use. Our goal here is first to set up a logical construct that represents the workflow that should happen, and then use your existing identity platforms to be able to verify that workflow is what it says it is. So whether we're talking about any kind of different types of developer tool, your GitHub account, your existing PKI infrastructure, your AWS infrastructure, et cetera, LDAP, Active Directory for on-prem. We have a number of different ways to be able to verify that a workflow is what it says it is, which is the first step, again, identifying that a workflow is what it says it is. And then in terms of verifying that that workflow has the rights and ability to be able to actually conduct that operation, Vault has an independent way of handling role-based access control that we call ACLs that operate on entities. And the best way to kind of contextualize this in a non-technical context is, I, Andy Minoski, have a number of ways of verifying I am who I say I am. In my wallet, I have my driver's license, a library card, a number of credit cards, debit card, whatever, et cetera. And within the context of what I'm doing, these are both ways to identify me as well as ways to entitle me to different workflows. Probably don't want to go to the library and try to use my Amex card to check out a book. Simultaneously, if I go to AWS and try to pay my AWS fee with my library card, that might not work out very well. And so the context in which I purport my identity as well as the workflow that it's entitled to imparts different sort of roles and responsibilities. And Vault has a way to be able to abstract that regardless of whatever your article of identity that you're using is. Additionally, while Vault has a way to just kind of protect any data at rest and in flight using strong cryptography, we can also orchestrate that workflow for you. And a good example of that would be something like, let's say that I want to give Vault a credit card number. We can absolutely protect that credit card number and give it to verified applications and workflows. We could also instead say, you know what, why don't I not give out the credit card number at all? Let me leave it completely encrypted with AES 256 single encounter mode at rest and in flight using whatever version of TLS you would like to use. And instead, I will actually generate a format-preserving string of data that looks like a credit card number, that looks like a MasterCard or a Visa or an Amex, but actually is not anything. And if an adversary steals it, if it goes in like a database and someone steals it, it doesn't give them any undue access or it can't be used in a data breach, et cetera. This kind of approach of orchestrating data is very different with Vault, and ultimately it lends itself to a situation where Vault is rather not just an encrypted database, but rather it's an orchestrator of data as a whole. Vault, over its, I guess, 7-year-long life, has had a number of accomplishments as a result of this. Vault and the Kubernetes community have been lockstep, tied at the hip for sort of the evolution of Kubernetes to where it is today, just because sensitive data needs to live in Kubernetes, and Kubernetes is a fantastic example of how do I handle ephemerality and different types of ephemeral environments. And so as a consequence there, when it comes to hardening and protecting things like Kubernetes secrets or protecting sensitive data within Kubernetes, Vault is a common pairing between the two. It is one of our most popular open source tools, having a nearly $16 million or 16 million download per year rate. And this actually is a very interesting point here. Trillions of secrets served per year. A significant portion of the world economy runs on data protected by Vault, to the point where, to contextualize where this number comes from, a very large financial organization once purported that if their Vault infrastructure was to go down, several countries will go to war with each other. So the stakes are very high with Vault, and we're very excited to be able to support these really critical workflows. But it's not just us; it's the community as a whole that uses Vault to be able to iterate on it, to respond to it, to give us feedback as a company on how we can kind of iterate with sort of features and other enhancements, and simultaneously how we can all collaborate to use this tool to be able to simplify the hard parts around cryptography. So yeah, as a whole, again, Vault really focuses on that machine-to-machine-based model of how do I handle the protection of automation workflows primarily, using this mechanism of I don't necessarily know where you're coming from, but I can verify that you are who you say you are. I have an independent way of handling role-based access controls to be able to ensure that you have access to data. And then finally, ways to orchestrate data in such a way that regardless of whatever the end result is of that data, that you don't need to take it out of encryption unless you absolutely want to. And again, that guiding principle of sort of how do I really think about using different workflows and different types of certificates or of identity, attestations of identity, in the context of protecting data security, that's a very different part of Vault. And so when we develop Vault, this was kind of the guiding light for how we look at the rest of our different security workflows. Is again, we assume that you're going to have a variety of different ways to identify your tools, your application infrastructure, et cetera. That's okay. We need to build products that allow you to be able to marry with that existing infrastructure and not try to override it, to broker identity as opposed to tell you what identity should be. Now, there are a number of different ways to consume and use Vault. One of the increasingly popular ways is to use something called HCP Vault. This is our managed Vault service that is available on AWS today. So rather than having to deploy your own Vault instance and think about things like how would I like Vault to encrypt itself, where I'd like the keys for Vault to handle its own independent encryption to live, all that's set up and you can actually just turn on and start using Vault immediately with this context. There are a number of benefits to using HCP, not just with Vault, but really with all of our products. But Vault really well highlights this. First, the ability to have a push-button deployment where, again, I just press a button and say, spin up a cluster, as opposed to think about things like auto and seal, identities and access management, et cetera. The infrastructure is fully managed. Vault has, especially Vault Enterprise, a number of ways to be able to harden against pretty much any kind of catastrophic failure scenario that you could think of. But again, that requires management. If you would like to not have to manage that context, we have ways to be able to implement those kind of strategies across different geographies and different regions and even different clouds, but to do so in a way that you're not managing it yourself. And then again, one multi-cloud workflow. Again, when I talk about sort of where those identities sit, when I talk about how those workflows sit, at no point was I ever like these all need to live within one specific place. Again, if we talk about any infrastructure, we need to build all our products here at HashiCorp to be able to look at things in an infrastructure and environment independent way, and Vault by nature does that. So it's really not that Vault is like multi-cloud, it's that Vault is multi-whatever environment that you want to execute it on. I think my favorite situation that I've seen with regards to this is Vault being deployed on AWS and then having a secondary cluster that was running in a mainframe. So that's fairly challenging and also really exciting in terms of if we can really build something that can run on ZOS somewhere and has like a tape drive backup while simultaneously running on AWS and no one using any of these systems knows that they're not talking to like the natural Vault system, I think we're doing a pretty good job. And that's kind of, again, more of our North Star of the kind of experience that you should have when using a HashiCorp product. So we talked about machine authentication and authorization. Now I want to talk a little bit more about machine-to-machine based access. Going back to that, the House of Doors model, this is the how do I make sure that no one can follow me home? Now, again, the movement from static to dynamic infrastructure can be very disruptive, but in the context of this could actually be a very, very big means of protecting your information and ultimately where a lot of your data as well as operations may reside. There's a tool that we have here at HashiCorp called Consul that really focuses heavily on service networking. And when I say service networking, what I mean is allowing you to be able to span application infrastructure, workflows, data across any kind of environment. Going back to, again, what we talked about with Vault and really all of the rest of our products here at HashiCorp, again, we don't want to tell you what environment you should be executing on. And one of the ways that we have to go, one of the challenges that comes up when we talk about provisioning, securing, connecting, and running any kind of infrastructure for any kind of application is ultimately dealing with the challenge of if you are truly going to go across multiple environments, sometimes those environments don't play well with each other from a networking perspective. Sometimes, for example, there might be kind of interesting IP tables configuration challenges. Sometimes the applications might not know each other application is friendly or who they are, et cetera. Sometimes disruptions may happen from a networking perspective that may challenge these things. This is ultimately where Consul comes into play. So what is Consul? Consul is a tool that allows you to do a number of different things. Serving as a multi-cloud service mesh, providing the capabilities to be able to do health checking and health monitoring for applications in that mesh, and then actually identifying and securing the data between all those applications. It is in that kind of example that I gave, it is the bus that you get on where I don't necessarily need to know where my home is, it will take me to my home. And it knows who I am because it sees the key that I have in my pocket, I check in on that bus, et cetera. So once again, just like Vault, I'm purporting your identity, this time now as an application in the context of networking, and I'm able to deal with any kind of complexity associated with having multiple environments that I need to span across. But now it's a little bit more interesting in the context of this can be a way for me to handle and protect against adversaries that for long periods of time are watching my networking patterns. Because there's nothing to watch because everything's A, encrypted, and B, everything's moving around and shifting constantly. So the multi-cloud service mesh aspect of Consul is probably its most popular example. So securing service-to-service connections. And what I mean by that is, when I have sort of TLS connections or any kind of other encrypted communication that needs to happen, there's a lot of crypto that needs to happen with regards to how a CA verifies applications are who they say they are, how to handle sort of the vagary of situations where there's key exchanges and things that need to happen, and ultimately connecting applications across different networking infrastructures in a way that I can span virtual networking across all of them. This is really the heart and soul of what Consul is, as well as what service meshes as a whole are trying to focus on. And the way that Consul does this is built in such a way that, philosophically, Consul doesn't want to tell you what some of these components need to be. You might have your own existing PKI infrastructure, maybe Vault, may not be Vault. That's okay. We just allow you to be able to plug into that, to be able to verify applications are who they say they are, that you can create secure tunnels to be able to communicate across communication between them in an encrypted way, and then ultimately these applications can talk to each other. This talk to each other part is also a very challenging problem, especially when you talk about having more ephemeral environments that might be executed, where I might spin up a pod in Kubernetes, I might deploy an EC2 instance, et cetera, and I might have a very short window of time where there exists a networking connection between one application and another application. This is really where Consul's network infrastructure automation components come into play, where by having a service mesh where I know that every application is what it says it is, I can then thread networking connections between them such that from a developer point of view, I don't need to worry about figuring out new IP tables for a thing that's going to disappear in about 10 seconds. So this infrastructure automation part is really dealing with a lot of the complexities associated with that static to dynamic movement. But from a security perspective, this is actually a really good thing because at no point then do I need to expect that something is going to be at a certain location. Common way to be able to break into infrastructure is to break routing tables or otherwise hack into something and then be standing there when someone says, give me a sensitive piece of information. By having every application be verified and then having sort of that connection piece between them be purely automated, it makes that kind of style attack really, really difficult. That kind of very specific man in the middle, post-exfiltration spear phishing attack, which unfortunately has become very common, but is something that can be very well defended against if everything that is in the data center is known to be there and all the workflows are connected together in a very prescriptive way. So just like Vault, Consul's real focus is how do I deal with those three challenges at the networking layer? How do I deal with challenges related to identity and access management, verifying different types of like identities, in this case, the various identities that might attribute to an application workflow, verifying that those workflows are entitled to be able to communicate with each other across a variety of different domains, environments, et cetera, and then ultimately that the data there is protected, in this case with TLS or your SSL or your channel encryption of choice. What's interesting about Consul, by the way, is that Consul is also probably they Terraform and it battle sort of like for popularity, but arguably our most popular open source project. And there's a number of reasons why, but it's very interesting to see Consul just kind of pop up in a lot of different places, especially given that I think arguably HashiCorp was most known for Terraform as a developer tools company. Just like Vault, the disruptive aspect of Consul is really around this idea that applications are the center of focus. And when I want to sort of think about how applications are communicating and handling those three key problems again, it's really on that application-specific focus as opposed to the networking focus. So networking may be the domain that Consul operates in, but really the focus on the application makes it a lot easier to be able to, a lot easier from a usage perspective to be able to handle these workflows of protecting communication between applications, verification of that application to enter the certain networking domain, and then ultimately to thread secure encrypted tunnels between them. By doing that, it's our goal in handling the complexity around how do you actually do that from a Consul perspective means that it makes it a lot easier for developers to be able to write applications without having to have a deep background in networking, as well as like a constant understanding of what's going on within their infrastructure, which they may have like little to no visibility into. Just like Vault, there exists a version of Consul that's self-managed on HCP. It's at hashi.co/cloud platform. And just like Vault, again, there are a number of different ways to consume Consul, but HCP allows you to kind of deal with this in a way where you don't have to manage it yourself and can, again, specify sort of how you're given your threat model and your thoughts around what resiliency should be to encode that in such a way that you can kind of set it and let it go. The last component of our kind of multi-cloud security story, our zero trust story, is really something called Boundary. And this focuses on human to machine-based access. So again, machine authentication authorization and really Vault's way of trying to think about how I abstract identity, how I abstract workflows, how I abstract credential management is very interesting, but when we throw a human into the mix, things get a little bit more complicated. There's a lot more differences that you need to think about in terms of usability, as we've learned. Boundaries are a way to specifically focus on that. And to kind of give you an example, I want to contextualize a story about how a user should establish identity. So let's say that, for example, I have a private single sign-on service that might be something like an LDAP server. I have a cloud-based single sign-on service that might be something like an Okta or AWS or Ping Identity. When I have these different domains of existing identity, and again, we don't want to tell you to use one of them or the other. We expect that there's going to be one or multiple of these things that exist. It might add a little bit of complexity in terms of how a user might actually identify themselves and then gain access to a resource. In a very traditional fashion, what might happen is that, In a very traditional fashion, what might happen is that a user will have to go first to talk to different groups. For example, they might have to go talk to a group that handles specifically that private domain of information to be able to request access. There also may or may not have automation that exists to be able to leverage something like AWS IAM or like an Okta to be able to access those resources. And then they have to like get a credential, fish it out, and then hopefully access something in a secure fashion. That's a little bit challenging, and that can, as we will see, provoke a number of different ways that an adversary might exploit it. And that's really kind of where we first started to research, maybe we should build something here that does this a little bit differently, because just putting Vault out there and saying figure it out yourself doesn't really seem like a responsible way to solve that problem, and there's a lot of opportunity there to kind of change that. And again, what's really interesting about this is that just like all the rest of our products, this is really focused on something that is an identity-based access control. Again, this is really about a non-infrastructure specific way of verifying an identity in a workflow. Boundary just takes this and contextualizes this more to the human experience. But again, just like we talked about or saw before, you have a number of different ways to verify that identity is what it says it is. Boundary is also available on AWS already, and actually we just released its GA version very recently. And the consequence of that's actually really cool because there are a number of different ways for Boundary to consume both on-prem and in-cloud applications when it's run purely on AWS. And just like Vault and Consul, you can specify failure zones like fallback, et cetera, et cetera. Let me contextualize a little bit of actually that workflow of how Boundary might work within that context of having multiple different ways to verify a user's model of access. So in a traditional model of access, I might have to go in and request access to the VPN to be able to connect to something like a Bastion source or an SSH source. So that's difficult because there's, again, as we saw before, depending upon my methods of identity, there might be multiple teams that actually handle that process. They got to file a ticket and hope that everything works out for the best. Even then, when I connect to a VPN or Bastion source, I have to then be granted network access, which is complicated and challenging because just like we talked about with Consul there, if I have like long-lived static network access, that's something an adversary could monitor and use as a mechanism to be able to potentially attack my infrastructure. Or at least attack components of my infrastructure to be able to debilitate service and ultimately cause outages. And then finally, I've got a firewall. And with that firewall, that might be something that ultimately lends itself to a challenge related to, I might have rate limiting issues, et cetera. IPs themselves are brittle. I got to set up IP tables. And so all of these lend themselves to, there's a lot of different teams I've got to talk to potentially within an organization. There's a lot of different people that are involved. And then finally, even if all of that really works, I got to get a credential from somewhere. And now I have to trust, as an infrastructure team, I have to trust the user to use this credential responsibly and not have the credential stolen. As a user, you have now forced me to defend this credential against your entire threat model. And that's a pretty unreasonable expectation, depending upon what user you are, what organization is using this, et cetera. I mean, if I'm, for example, just in someone who is trying to access a database at a Fortune 500 company, I may not have the security training to be able to think about the context of all the different types of spear phishing attacks that you might see. And it's kind of unfair, ultimately, for that user to have to then suddenly become effectively part of the security team just because they've been given this credential to do their job. The dynamic workflow for access that Boundary really focuses on is trying to deal with those kind of different points of lots of teams, lots of complexity around how a user gains access to a system, and the fact that even credentials are involved in the first place. So first, when that user logs in using Boundary, you're logging in using a trusted identity. But again, just like with Vault or with Consul, we effectively make the verification of that identity something that the user doesn't have to really think about. When I mean that, for example, if that user comes with an LDAP or Active Directory credential, that's okay. If they come with a single sign-on credential from Okta or Ping or AWS IAM, that's totally okay too. We can set up automation to be able to basically make it such that the user's method of attestation is not strictly tied to just their way of identifying the logical user themselves, just like with Vault, just like with Consul. Again, their ability to have entitlements to different types of roles and access can be something that can be encoded pursuant to their means of access. What I mean by that is that just like with Vault, where I could say, hey, I come in with my driver's license. I'm probably going to use that for a driving workflow. Don't use my driver's license as a means to pay my my power bill necessarily, unless I really want to. We can establish the same kind of workflow with Boundary, where I can have role-based access that is built with the workflow in mind, with the user's access model in mind, and not specifically the method of attestation. I have the ability to do that in such a way that everything is not so strictly tied together, and the user doesn't see this at all. They just log into Boundary and go off to the races. Finally, the network remains private. Now, this is a little bit complicated, but suffice to say, what this means here is that the user doesn't know the IP of what they're trying to connect to. This is something that's completely shielded from them. In Boundary, they'll connect in and they'll just say, give me a Windows box, give me access to this one database, et cetera. And Boundary will shield all of this from them. Now, Boundary can do a lot on its own in terms of being able to protect where the different resources, or what we call the targets are that a user might be trying to access are. But it gets really exciting when you combine it together with something like Consul, where there's a service mesh, where not only does Boundary, the user not know where things are, Boundary itself doesn't know where those things are. It communicates with the service mesh and says, hey, I know based off of where a worker that might tell me where something is, that this exists. Can you connect us together? And so, when no one knows where anything is except for the service mesh from a networking perspective, it makes it really, really difficult for an adversary to try to study your attacks, study your access patterns to purport an attack. And finally, by connecting automatically, when the user connects through Boundary, they just jump into the system. And this is very different because they don't gain access to a credential. There's no copy and paste of a password that they need to do. They just say, give me a box or give me a target, and they jump there. And that's very, very different because For one thing, it minimizes the possibility for an adversary to like jump in and man in the middle and steal that credential. It minimizes the possibility for an adversary to go in and like leave like ransomware or other types of mechanisms on that user's box that might restrict access to static credentials that otherwise need to be long-lived for other users to use them, like vis-a-vis check-in and check-out functionality. Ultimately, it relieves the burden of having that user suddenly need to defend their own information in their own systems because now they have this highly privileged credential. And this kind of goes back to something that we talked about with Vault, where it's like, maybe I don't give you the credit card number, right? Maybe I just give you this thing that identifies for it. Maybe I just give you this like piece of information, this kernel of information that you could use and leverage within the context and that actually solves the problem for you. But actually, if the adversary steals it, they don't gain undue access infrastructure. Well, Boundary highlights that with a user, that might even be more serious than it is with machine-based authentication problems and machine-based automation problems. Maybe I just don't give them anything. Maybe the user just goes there and suddenly they're no longer part of sort of the threat model that I have to worry about because there's nothing there to steal. So really Boundary's focus is on how do I make sure that the user does not necessarily have to be part of my threat model, that they can go in and continue their operations in such a way that it's non-disruptive, but that they can gain access to these systems even in an environment where these systems move around a lot, even in an environment where credentials need to be resourced, and sometimes those credentials are static, and hopefully, in many cases, those credentials are dynamic. Boundary, just like Vault and Consul, is built in a world where we don't necessarily know what kind of environment you're going to be running it on. We don't necessarily know what kind of infrastructure you're running it on-prem, in the cloud, et cetera, using multiple ways to verify identity. Also, what's really interesting is multiple ways for protecting and generating credentials, right? Boundary also isn't going to tell you, like, use Vault or use a specific type of service or application platform to be able to protect credentials or even generate them. And this really highlights an interesting part of like our zero trust story, is that while here at HashiCorp, our products are built to work better together, they also are built to work independently. So maybe zero trust is something that you focus on in such a way that you have differences in sort of your infrastructure applications, and maybe you don't need Vault. Maybe I just want Consul or Boundary, or maybe I want just Consul. That's okay. Our platform, like our products, are built in such a way to accept all types of platforms. So what's interesting about this is we talk about HCP Boundary versus a self-managed version of Boundary. The access model is a little bit different, but they're built in such a way that it's not disruptive at all. Whether we're talking about self-managed environments or we're talking environments where I'm running Boundary as a fully managed product in the HashiCorp Cloud Platform, these are all built in such a way that they can actually address and access different types of target systems. You'll see the word worker pop up in Boundary. Boundary is really cool in that what Boundary does is it has ways to be able to deploy environment-specific workers to be able to conduct transactions there. So that worker might, for example, be within one environment resourcing a credential and then storing it in a protected way. It might be able to go in and say, okay, I know where the networking location is for something like that, send a user through me to be able to access a specific target system, et cetera. Both, whether you're using it for HCP Boundary or you're using self-managed workers, we can address both cloud workflows as well as on-prem workflows because of the flexibility of this worker model. And if you're interested in distributed computing, as well as like distributed state management, all of these aspects of how Boundary works here is actually all open source. Highly recommend you take a look at it because it's really interesting. It's a lot of really fun challenges we had to go overcome, and I think the community has given us a lot of great feedback on it as a result. So yeah, overall, our real focus on zero trust here is really about how do we as a company build products that allow you to be able to, regardless of whatever your identity platform is, regardless of whatever applications you have, regardless of whatever data you have, to solve those three key problems. You verify that every workflow's, the creator and originator of that workflow is who they say they are. You verify that they have the rights and entitlements to be able to actually access the things within that workflow, to access the data that workflow is going to be accessing. And finally, the data transmitted within that workflow, you protect it. You protect it in such a way that it is protected against an adversary being able to record it, to break it later with strong crypto-analytical or code breaking techniques. You basically remove the complexity associated with how do I deploy cryptography to protect that data at rest and in flight. And you tell us what sensitive means to you, and we automate the process of protecting that sensitive information. And we do this all in a way where identity is not something that is strictly tied to specific aspects of that, but ultimately verified through whatever kind of identity service that you have. To be very specific to AWS, I'd love to kind of walk through what this might look like within an AWS infrastructure in particular. With Vault, managing machine-based authorization. So Certainly, Vault can authenticate pretty much any way you have to deploy a service on AWS or application on AWS, EC2 instances, AWS IAM roles, et cetera. So if you have a native workflow in AWS that needs to go authenticate in, especially if it needs to authenticate in and talk to other services that live outside the context of AWS, Vault can certainly do that because the auth methods within Vault are able to verify all these different ways. But similarly, because Vault can broker these different types of transactions, we have a number of different ways that are AWS specific to be able to handle like credential management workflows, credential generation workflows. Things like the AWS secrets engine within Vault. If I wanted to generate IAM roles that are one-time use that give an app the ability to be able to do something within AWS, but if an adversary breaks in and steals that credential, they don't gain undue access to your AWS infrastructure. Something that's a very common use case with Vault in particular. Additionally, there's a mechanism within Vault that allows Vault to be able to be the bearer of cryptographic keys or the originator of cryptographic keys, and then to matriculate them and manage them outside of Vault within the context of things like AWS KMS. So if I want to have keys that are created by Vault that leverage hardware-based cryptography, things like HSMs, et cetera, but then Vault handles the rotation of that key material, the storage of key material, CA aspect of it, if we're talking about PKI, we can have that all live within the context of KMS, and Vault just handles the rotation and automation of the presentation of that key material. In the case of Consul, Consul service registry, route accessing tools, all of its networking automation tools all work natively within the context of every kind of networking part of AWS. So if we want to go marry EC2 instances together, that's totally fine, as well as like resource, an AWS EC2-based application with another type of service. Consul is built for specifically those kinds of use cases. And then finally, human-based authentication here. You absolutely could use Vault to be able to generate like dynamic certificates or dynamic IAM roles for users and then let them go through and go handle things. But in the context of this, we really want to provide a good, strong user human experience for that operation. And so Boundary today has like services to be able to handle pretty much any native authentication service with AWS, and they do so in a purely automated way. And all of this works whether we're talking about on-prem, in the cloud, self-managed, or with HCP. So really excited this provides you a lot of flexibility, but within the context of AWS, we've been very blessed to have a good relationship with Amazon. As a consequence of that, everything kind of just works together naturally. Well, thank you so much for your time. We've got